Years ago, we started Reactive Ops first and foremost as a services company. For us, that means humans helping humans be great at very difficult things. Since then, we've seen a massive shift in DevOps culture and tooling. We want to prepare you for the future of cloud infrastructure and help save you from the many mistakes that we've made along the way. We don't just want to do Kubernetes for you, we want to help you do it for yourself. We'll do that here on this podcast and a whole lot more. In upcoming episodes, we'll talk Kubernetes, leadership, and DevOps culture in general in ways that we hope will help you and your company successfully navigate the cloud. This is Environmentally Friendly, and I'm your host, Kendall Miller. Welcome to this new podcast that we're trying out, and we're still figuring it all out. But today, for the first episode, we have
Lance Smith. I'm an engineering lead at Reactive Ops.
Kim Schlesinger. I'm a site reliability engineer at Reactive Ops.
And Nick Huanca. I'm a site reliability engineer at Reactive Ops.
And I'm your host, Kendall Miller, also at Reactive Ops. So today, for this first episode, we decided we were just going to dive right into some of the history of Kubernetes, how we got to where we are today, and talk about why it's relevant to the industry, why it's making people excited about the future and where we're going. So, first question. The first time I was writing code, we had a server room in the back room that we walked to with a CD, installed code on it. Were any of you writing software back in those days? Did any of you ever deploy to physical hardware, first of all?
Yes.
Okay, and what was that like for you back then?
It was painful because you had to figure out a way to manage connections, get in, make sure you didn't have any downtime, how do you rotate machines out, problems that were really difficult to solve.
And you actually managed to do it without downtime?
No, that is false. I did it with plenty of downtime.
I was going to say, when we did it, we had the site is down for scheduled maintenance, and yes, it would take us 2-3 days to get everything through Q&A and then proceed. But
yeah, maintenance windows used to be a regular part, especially doing SRE work. You would schedule maintenance for things to be offline for a period of time.
And today, when you go use Amazon, how often do you see site down for scheduled maintenance?
Depends on what region you're using, but
if you're going to buy something on Amazon.com, they're never down. No. And if they were down for 20 minutes, they'd probably lose millions and millions of dollars, right? So we live in a different world today. So let's talk a little bit about how we got there. So there was physical hardware. I mean, people were hosting websites on their own computer in their basement for a very long time. And if you couldn't get to it all the time, that was fine, right? But then we moved towards servers and a greater expectation of uptime. And then from there, the next sort of iteration was virtual machines. Talk a little bit about virtual machines. What was it like to package up a virtual machine and deploy something from it?
There was a lot to it, really, and it had a lot of variance in terms of people's opinions. So when you go change a job, or maybe a new person comes on or leaves, then a lot of those opinions can come and go. And it was a really difficult packaging something stable for everybody to use, in my opinion. The difficulty being the incredible variance for options in terms of operating system, or what were all the different code? I come from a kind of a Linux background, so making sure that all the right versions of the packages are installed. Image magic was a nightmare. Things like that, if you had to do any kind of image manipulation, could get really hairy, especially with security updates. So you re-roll all your VMs, and it was a lot more overhead.
Okay, and for people who don't know the specifics of what a virtual machine is, I think a lot of people picture, the early days of running a Windows box in a window on top of your Mac, or the other way around, as the case may be. I mean, that's sort of a very high level what a virtual machine is, but is there a maybe better explanation, or is that the whole thing?
Well, it's pretty accurate. I mean, technically a virtual machine is something that, you have a base operating system that lives on hardware, and you have a hypervisor, which is a translation layer that sits in front of that and allows for any number of guest operating systems to sit on top of that.
And so then when you're deploying virtual machines and you want to have, you have a huge uptime need or a massive scaling event, why were virtual machines difficult to orchestrate? We're working up to Kubernetes here, so talk about the things that were painful before Kubernetes, if you can remember that far back.
Yeah, I mean, you're still bound to physical hardware, right? So, and even in cloud talk that you have today, you're still bound to physical hardware, but that's abstracted so far away from operators who are actually running infrastructure. But when you're running something like VMware, which is probably the most popular hypervisor manager for virtual machines, you were still bound to the hardware that you had running in your own cabinets in your own data center. So a massive scaling event would literally take your engineers to have to go down and physically rack and stack new hardware, install base operating systems, install a hypervisor, and then figure out how you were going to bin pack virtual machines on top of that.
Okay. So in addition to just saying I want more virtual machines, you also had to figure out the hardware piece behind that. Were you ever deploying more than one virtual machine on a single server, or was it usually one-to-one?
Well, no, that was the offering of virtualization.
That was the whole beauty of virtualization. That's what made that a big deal. Yeah. So then we move into containers. What did Docker do for containerization? Containers were around before Docker with LXC and I guess a few other things, but what does Docker make easier, maybe from a developer perspective or from an operator perspective? Why did that matter?
To go back to the virtual machine to paint the picture a little bit more, when you to your scaling event, I needed 10 more servers, you'd be booting all of those VMs, which includes initializing all the memory for the operating system that runs inside the VM. Docker abstracted that away a little bit to reuse effectively a VM, so you really only have the overhead of starting your application versus starting the whole operating system and everything that's required to get the app running. So kind of LXC kind of containers normalize that to a little bit more packageable and easily startable package.
Easy packaged it to a nice, easy package. But the packaging is important because it used to be a physical piece of hardware, then it was a virtual image, and now it's an easier to operate with package. The package is getting smaller, easier, faster, lighter weight for all kinds of reasons, right? Is running Docker on a local machine easier than running a virtual machine? When you're, I guess not even just running it, but deploying to or testing with or all of those different pieces?
Yeah, Docker normalized the manual way of doing it. There were ways of doing it beforehand, but putting a common API in front of that is effectively what made things a little bit more accessible. So how you package a Docker image, for example, made it a lot easier to ship around artifacts that you build, in a different place.
Well, and as someone newer in the industry, Docker is really accessible now. There's a huge global community, a lot of tutorials, and it's definitely possible to learn how to containerize using Docker fairly easily now. So.
Absolutely. I think the introduction of Docker is sort of your common runtime for containers, which is different from LXC, is that there was a CLI that came along with it. So there's a lot of questions that you would have to answer manually if you were using LXC and talking directly to the Linux kernel and having to manage namespacing all on your own. And Docker, when it first came out, handled all of that stuff for you. And I think that containers always, for a long time, had great promise in terms of making it more repeatable, making it faster in order to spin up these pseudo virtualized environments. But it just wasn't really accessible to people. And when they had this toolbox effectively to be able to do that really easily, it started to gain widespread adoption, and you started to see communities pop up around it and a lot more a lower barrier for entry.
A friend of mine has described it as containers have been around for a long time. Docker made it usable for mere mortals. Is that an accurate description? LXC was a little more difficult to use. So to back up just a second there, it has these different layers of abstraction from server to virtual machine to container. Did that ever reduce the developer, it works on my machine problem? Or does adding that abstraction improve things or not?
Well, you can still get yourself into trouble for sure, but I think adding that abstraction definitely improved things, especially when you're talking about how packages used to be installed with RPM or Debian packages. They relied almost wholly on what the system had available to it at the install time. So somebody developing locally on their laptop might have all their jars and libraries installed on their laptop, and that's why it worked on my machine. But when I take only the composable artifact and put it into another environment, that's where things go awry. And containerization kind of tries to encapsulate that environment holistically, so you can kind of run it in the exact same way on your laptop as well as like server aspects.
Because you build out a base image, it assumes certain dependencies, and then it assumes certain versions of of all kinds of things, and then when you deploy your application to it, that's uniform across however many different containers, or wherever you're running that container, because the container packages everything so nicely. Okay.
You know, I think that especially when VMs sort of came on the scene, you started to see this trend towards immutability, and I think that that was to address exactly what Nick talked about earlier, which was dependency management, right? And how do you get the same piece of code to run the same way regardless of what environment you put it in? And so, you know, when you're taking the overhead of spinning up a virtual machine and then installing all your dependencies, and you know, are you version pinning all of your dependencies correctly inside of, you know, whatever config management system? So you introduce like all these layers of complexity. And when you add containers into that, you are able to do something that's truly immutable, that you can run the same on your laptop, on a VM, on a piece of hardware, in a cloud orchestration system that we'll talk about in a little bit. And so it made even that idea, which is paramount to stability, that much more accessible.
No, that's all helpful. So now we've worked from server up to container. And Kubernetes is the next layer above that that's actually orchestrating those containers, right? Is that an accurate description, first of all? Do I need to pull my foot out of my mouth before we continue? Okay. And then talk about why orchestrating containers is hard work. I mean, can't I just deploy a container to a server and say, hey, go, and then we're good to go?
In my opinion, a lot of the orchestration systems provide like some plumbing, freebies. So, you know, you can get something running on your laptop or anywhere pretty easily, same thing with as a server, but then like how does it get accessible to the internet? Some metadata around like routing traffic to it, that becomes really complicated. And Kubernetes kind of is one of the ways that you can really normalize how to interact with your infrastructure really, and how the plumbing gets to your container so you can serve the right traffic at the right location. And so that's kind of, in my opinion, like some of the orchestration pieces that are kind of freebies, and there's a lot of others that I'm, you know.
So, and Kubernetes has sort of removed the need for traditional configuration management, right? In most of the situation, because it's kind of it's handling a lot of that orchestration, et cetera. I mean, just talk a minute about why you're not using Ansible every day, all day long anymore. Because we were for a while.
You know, I would say that even more so than just Kubernetes by itself, I would say Kubernetes as a managed service with something like GKE is what really removes the need for traditional configuration management, because we as operators are no longer working on the VM level, right? Like we are just looking at this API, this common API that can be the same if you provision it on hardware, virtual machines, or it's a fully managed service. So that's what I think really removed configuration management from our day-to-day.
So you're still using configuration management when you're setting up Kubernetes in an environment that doesn't have a managed Kubernetes service.
Correct.
And that's why all these cloud providers are working really hard at bringing managed Kubernetes services to the data center and all these other places, right? Then everybody gets to work with an API and forget about servers almost entirely, which is kind of the dream, right? We all forget about servers. Okay, that's helpful. So then talk about that for a second, Lance. Like if there's a common API, it sounds like the dream that if I build it with Kubernetes, I can run it anywhere is a reality. Is that true?
I think it is, yeah. I mean, I think that, you know, having Kubernetes, having a common API that you can use to schedule your workloads, to define what your network's supposed to look like, to talk about the plumbing, you know, how traffic gets to the right services, the right time, to do things like canaries. Having that all have the same configuration that can be defined the same way and moved from one cloud provider to another into a data center does reduce a tremendous amount of overhead.
The myth of cloud agnosticism, as we've heard of, isn't a myth?
I would say that there are still hurdles to get over in order to be truly cloud agnostic. You still have to choose a place where you're going to run your infrastructure. You don't get to magically, say like, hey, sometimes my traffic goes here and sometimes it goes into another place. Those are solved problems with a lot of complexity. But yeah, so it's still a hard problem to be completely cloud agnostic, but we're a lot closer than we've ever been.
And is that because you end up tied into each individual cloud's managed services as well? Like the entire infrastructure doesn't run inside Kubernetes today, does it?
Correct.
For most people. You probably could, I suppose, but Okay, we'll talk about that. What kinds of things are people running outside of Kubernetes that matter?
Data layer stuff mostly, like RDS or like Cloud SQL kind of things. PubSub type of things, like, so anything with queue-based, in my opinion, is usually a good thing to run outside of Kubernetes.
There's ways to run those inside of Kubernetes, but you still advise against that.
I mean, it depends on your need for complexity. So, I mean, all technical decisions generally add a layer of complexity. So if like the cost-benefit analysis like makes it worth assuming the risk, then, you know, fill your boots.
So say I'm, let's come up with a fun name. Bob. I could have done better. Jim. I'm Jim, CIO. I got nothing. And I'm trying to figure out where to run my workloads. The reason that I choose Kubernetes is because, in theory, it frees me up to not be locked into something for forever, right? In 5 years, if I want to move, it's easier to move if I've built the infrastructure in Kubernetes. Is that part of what we're saying?
I'd say theoretically, if you're looking exclusively at like, you know, what you're doing with your workloads, you know, you still have persistence to manage, right? Like like what Nick was talking about, data layer stuff. Like you're like every application stack, almost every application stack has persistence that lives somewhere, right? And so with that, you know, that's where a lot of your vendor cloud lock-in comes from. But again, from a workload standpoint, you are able to transition workloads between providers a lot easier. And, you know, let's just say that you have compliance concerns or something that has you running part of your workloads in the cloud provider and part in a data center. Like, you are able to define those the same way, deploy them the same way. They just have, you know, two different spaces that they run in, and that's your separation of concern.
So Kubernetes is basically a miracle worker?
I think that is true for sure. But like what Kim was saying is like the community also makes things a lot more normalized. Like there was a lot of splay in opinion, like I was talking about earlier, like between how you might install a server, what packages you might include, how you manage that stuff. Having a common set of APIs and a community that implements them all pretty much the same way, there's not as much divergence. And so you have a better pool of people that kind of know how to do something the right way. In my opinion, to like a CTO, CIO level, the benefit is like also the community. You know, how many people are adopting it, how commonly you can search for help on it, how many, you know, service providers are backing it in terms of like either managed services or people out there. So I don't know, I think that's a big kind of soft benefit anyway.
Sure. Well, so then just talk personally for a second. As people who've been in this industry for a long time working with these similar kinds of technologies, what does Kubernetes enable in terms of like what you just like about it? What's nice to work with inside of Kubernetes? What are the problems that you don't have to solve today because Kubernetes has solved them for you? Like when you first used Kubernetes, was there a breath of fresh air around anything specific? And if so, what was that?
I think so. I mean, everybody to your left has the word reliability in their job title. And I think that, you know, for somebody who's spent the last decade being on call, being responsible for uptime of services that my company, you know, product company provides, you know, being able to have really, really fault-tolerant infrastructure that sits behind what your software you're running sits on top of has been completely invaluable. I mean, you know, if I could graph the number of pages that I've gotten over a period of time, you know, I mean, it'd be a reverse exponential graph as cloud adoption has become more and more prevalent, and Kubernetes has dropped that off to, you know, a very, very small amount.
Because it's killing off services that are dying for some reason and bringing up new ones, and it doesn't even have to wake you up for that?
Sure. I mean, that's the definition of a scheduler, right? Is sure. That, you know, you sort of throw over the wall what your configuration should look like. You know, I need to have this amount of work scheduled and be up all the time. So if the server disappears, you know, the Kubernetes management layer, managed control plane will say, oh, I see that some of your work is missing. I'm going to go find a different place to put it. And for me, that means I don't have to wake up in the middle of the night and solve that problem.
Okay. And then Kim, being newer to the industry and coming right in with Kubernetes, essentially, talk about like what's been nice to work with, what's horrifying, where you hope it maybe goes in the future.
So I think the nicest thing is that there's just a lot of documentation, there's a lot of blog posts, tutorials, there's a huge Kubernetes community. And so it's a big, wide open discipline, but I don't feel like there's any lack of technical documentation or asking for help, which is really neat. Lance mentioned it, but I just think it's amazing with Kubernetes. You basically just say, this is how I wish the state of things to be, and Kubernetes makes that true. And even though I haven't been in ops or infrastructure all that long, it feels magical. It's like, oh, I say this, and it actually looks for that and tries to make that state true. So that for me, as a web developer and someone relatively new, is like, wow, you just say what you want, and for the most part, it's there.
But there's been further abstraction for a long time. There's been things like Heroku that solve the entire infrastructure problem for you, and you don't need to worry about it. So let's talk for just a second about Fargate. What does Fargate enable, at least in promise? And then, who's going to not use Fargate? Like, what is there a level of complexity that you require, and then therefore Fargate's not going to solve it for you because you need to get into the minutia of it a little bit better? Or, why not just hand a container to Amazon and say, it's your problem? Isn't that what Fargate promises, first of all?
Kind of. I mean, there's also ECS, which is a similar kind of scheduling platform. But I think it just depends on your business needs. Like, yeah, the scale, like you mentioned, it really depends on how much you want to do with your infrastructure and how much you really want to abstract, and also, cloud portability, like we were talking about earlier. Big providers sometimes are very opinionated on how they do things, and Kubernetes is as well, but it just depends on maybe what paradigm fits best with your organization, in my opinion. I mean, there's like always a cost-benefit analysis.
But for some level of the population, the simplicity of that's going to be a godsend. And for some percentage of the population, the simplicity is going to be too simplistic and they're going to need more control. Is that really all it boils down to?
With most things, I think. Like, for example, we used to use Elastic Beanstalk for deploying certain applications, and we hit like scaling limitations in terms of how quickly we could do releases. So when people started really wanting to run or like sprint on like releasing really in short intervals, some of the paradigms and like decisions that the provider made with Elastic Beanstalk didn't like facilitate that for the business. So like we had to shift. And that's kind of what we were looking at Kubernetes for originally, my previous gig. And yeah, so that's maybe an example of sometimes when a cloud provider's decisions don't work out for your business needs.
And I think that the evolution of open source technology is important to talk about, because when you talk about a vendor-specific service versus a managed service that's based on open source technology, and Kim talked a little bit about the Kubernetes community and how important that is. So you have this community that's coming together around open source, that's iterating and releasing and providing updates that you get with your maybe cloud managed services, or maybe that you're running it yourself in the data center. And you don't get that same thing with a vendor-specific service like Fargate or ECS.
And you're saying that's a big enough benefit to make it worthwhile to use something that has that kind of community support.
Sure. Like Nick talked about Beanstalk, which we've all used probably in some capacity. It's effectively become antiquated, right, in favor of containers, and you might see the same thing happen. I think that serverless we'll probably talk about a little bit, but you're seeing these different offerings kind of start to splay off, but Kubernetes is encompassing all of those.
Well, and with the open source, Kubernetes being open source, the people who use Kubernetes every day get to say, this is an issue or this is a feature we want, we'll build it, but it's evolving in a way that's in alignment with a lot of business needs, because it's evolving in the way that people are finding rough edges and then fixing them.
Because it's community driven.
Yeah.
Okay. So then shift and talk about serverless for a minute. First of all, what is serverless or functions as a service? Just describe like what the actual interaction with that looks like, and then talk about what the implications are for the future of infrastructure engineering. Is everybody going to throw away everything? Is it going to kill Kubernetes?
I don't think so. We used serverless extensively, or at the previous place I worked, and it has its limitations, and it's hard sometimes for people to scope down their domain of like what they're incorporating into a serverless function. There are also limitations in the technology. I guess to talk about the technology a little bit, it's basically like write a small function and you have a common API of how to inject information into that function, and then a common way to get out the information that the function provides. And enter your business logic inside the function. And so the idea is that like they're kind of fired up randomly and short-lived, and can process, or or long-lived, but there are some limitations there with certain service providers. But I think that the speed and it depends on the speed and complexity of like the application you need. It's another tool in the tool set.
There's already ways to run serverless or functions as a service within Kubernetes, right? There's a whole bunch of different projects that do that. I have this, along the lines of what you were saying, Nick. I mean, I have some belief that in the future there's going to be people running large, complex architectures inside of Kubernetes, and some piece of that will be a serverless architecture also running inside of Kubernetes that they can call upon when they need. And that's gonna, I mean, how does that work? Does Kubernetes spin up a pod, run that function, and then kill the pod, or is it more complicated than that? I don't know. Maybe you don't understand maybe you haven't looked into the specifics of it, but do y'all know how that works? And is that sort of the future, as people are going to be running it in a cloud agnostic way inside of Kubernetes, or is there advantages to Lambda? And I'm going to make this question even bigger. No, I'm just kidding. Go ahead.
I haven't looked into what underlies any of the serverless stuff, the serverless add-ons for Kubernetes at all. I know Lambda specifically does actually spin up Docker containers under the hood and then kills them after a certain period of time. I think what Nick said, right, it's another tool in the toolbox. Serverless supports like event-driven architectures really well, which inherently is a little bit different than microservice architectures technically, where you have chatter back and forth between services that are always up versus something that's like listening for an event and then fires up and does its thing and then goes away, right? So you can't, we deal with a lot where clients come to us and they say, hey, we're trying to break up our monolith and we want to do it the right way and we want a container orchestration system to be able to run that in. You're never going to go somewhere and like take somebody's monolith and break it up into serverless, right? Like there's a tremendous amount of overhead and time in that transition versus taking a monolith and breaking it up into microservices and running it somewhere in Kubernetes, or just run your monolith in Kubernetes, right?
So I have a hypothesis that I want to ask y'all's opinion on, and I think I've voiced this in a few different places, but my opinion is that in the next 5, 10, I have no idea how many years it's going to take, but Kubernetes is going to become as ubiquitous in cloud computing as Linux is, and it's going to essentially just be boring, and part of the assumption for, yes, everything underlying that is, of course, Kubernetes. Do you think that's an accurate assumption, or am I full of it?
It's possible, but I don't I've always been surprised at which direction technology takes. Like people can just have like happy accidents and like figure out something that's just like blows everybody's socks off and like is just mind melting. So I don't know. I think it's a big part of, I will say it will probably be a system at some point that somebody's maintaining for a long period of time. And like, who knows, maybe decades in the future, it might be the legacy thing everybody's cursing. But technology is just a funny beast. Like all the cool stuff kind of goes away every once in a while.
But everything's sort of shifting that way, barring a revolution of something better coming along. We're kind of headed towards this. I mean, in theory, somebody could come out with an operating system that completely wipes Linux out, right? Like, it just hasn't happened because Linux has been good enough and become ubiquitous enough and has the community support. Arguments about BSD aside. Go ahead.
The primitives are like what matters, like being able to schedule things, good domain scoping, and like separation of concerns for infrastructure and like application running, forcing people to good paradigms of like application design. I think those things are like pretty constant in like most scheduling systems, and I think those kinds of things are going to live longer than maybe like a particular piece of technology.
Any futuristic comments, Lance, Kim, that you want to make about it?
I would say I would agree. I think that what has made Linux sort of a mainstay in technology, and especially enterprise scale operational technology, is sort of the need to have open source, the need to have a very scalable and malleable operating system that you can work with. And the need to replace that and the need to evolve on that has never really come up. I mean, it's still the base of everything that we run all of our enterprise, grade technology on today. I think that I agree with Nick that, hanging on to a specific type of technology, a specific abstraction that sits on top of that, because ultimately that's, what Docker and Kubernetes is they're all abstractions on top of the Linux operating system. And it'll be interesting to see what happens and see what happens, where it goes next. But those abstractions do tend to go out of style after a period of time.
Yeah, that's a good way to put it. The abstractions go out of style after a period of time.
Yeah, I do think though Kubernetes has like won the container orchestration wars, and it's becoming more widely adopted across all types of different businesses. And not only are ops people or DevOps people becoming fluent in Kubernetes, but your more like web app develop focused person is also becoming more fluent in that. So I think it's just becoming part of the language of being a technologist, and probably will be for the next few years.
Yeah, I think that, the reason that, one of the big reasons that Kubernetes has seen the large-scale adoption that it has is because of the governance around it with the CNCF. So I think, as much as, Kubernetes, the technology will be interesting to watch, I think it'll be really really interesting to watch some of these governing groups like the CNCF that are able to take large-scale community adoption, really sort of orchestrate it, right, in a way where you have this suite of tools that are, a suite of open source technology that is, sort of owned by the same entity and able to be managed that same way, and see how that drives technology versus the specific abstractions.
So the integrity of the CNCF is pretty essential to our future in this cloud computing world. That's
we all use Kubernetes every day because, it is what people are adopting at large scale, right? It's not the only container orchestration system, right? HashiCorp has Nomad, Docker Swarm is still a thing that people are using out in the wild. So, I think that it is governance of open source technology that has made it, really something that can be widely adopted. Okay,
so then let's shift gears. If somebody's sitting down to adopt Kubernetes today, where do they start? And Kim, you're newest to that community. I mean, dive into like, where did you get started? What kinds of resources are there out there that are super helpful for, let's start with the developer or the operations person that's interested in learning it rather than like the CTO that's interested in implementing it. But where does somebody who's interested in this technology go to begin?
Sure. So before I started working at ReactiveOps, I was a web developer, and I had not really done much with containers. And so just working with Docker and containerizing apps that I had already built was sort of my first step. Starting to play with Linux, if that's something new for you as an app developer, learning those commands or understanding a different operating system. And then there are some really good resources out there, Katacoda and Linux Academy and Cloud Guru, where you can containerize an app and then spin up a Kubernetes cluster in GKE or on Minikube and deploy that app into there. It's not easy, but you can do it relatively quickly and feel successful, and you get a taste of sort of the power of Kubernetes when you do that.
Nick, Lance, any other places you'd suggest for someone to go get started?
Yeah, Kubernetes is all operated from the command line, so getting familiar with the Linux command line. Right now Docker is the first class citizen in terms of what you're using to actually schedule. So in order to just schedule something in Kubernetes, you're going to need a Docker image that you're scheduling. So you should have some general understanding of how Docker works, and then the resources that Kim listed off were great. In terms of tutorials and entry points. The Kubernetes 101 blog posts are out there. I know that our VPE has a great Kubernetes Getting Started 101 talk that you can find on YouTube. There's other things like that. There's workshops in your area that some of the bigger cloud providers are putting on. Plug yourself into the community and see what's going on. There's meetups that talk about Kubernetes. If nothing else, just show up to one and understand 10% of it, and keep showing up until that percentage starts to go up, and you'll start to catch on.
Anything to add to that, Nick?
Not a huge amount. Just there's some open source tooling out there too, like Minikube, to kind of just get something running on your laptop if you don't want to sign up for a cloud provider. There's also Kind, K-I-N-D, which is a special interest group for running Kubernetes inside of a single Docker container, which is really interesting. So it's all pretty alpha, but it's a nice way to tool around with it. And I always find having a real a mission or some kind of a problem you're trying to solve helps frame you in a good place to learn something, because you kind of okay, I have this problem, how would I solve it with these tools? That usually helps as well.
Okay. And then say I'm a CTO interested in diving into this. I'm sure there's similar resources to just understand Kubernetes, but is it as expensive to shift? Say, I've decided this is the future. I want our company to have the flexibility that Kubernetes provides, all the functionality that it provides, et cetera. But we have this 15-year-old legacy application. Is it gonna be as expensive as people think to migrate to it? And like, when, if you're sitting down with that person, when do you advise that they make this change, and when do you say, yeah, your old architecture's terrible, but it's going to be a lot worse to have to rebuild everything to work in this new world? Or like, what are the sliders on that and the changes in that paradigm?
Whew, that's a deep question.
I'm trying to answer big of a question.
Yeah.
Just put you on the spot.
I think it's important to mention that Kubernetes is not a magic tonic for everybody's enterprise technology problem.
Can we cut that out?
What's that?
We're just gonna. No, I'm kidding.
So Kubernetes made me grow hair again.
Yeah, that's.
No, I mean, and so I think that the term cloud native architecture exists for a reason, right? I mean, there are ways that you are designing and building applications, and using microservices that lend itself a lot better to things like Kubernetes or just cloud in general. So I think it's important to consider that if you are the CTO that wants to wholesale shift over. I think that as far as overall cost, where I see people running into problems is this sort of idea of like, well, we just want to dip our toe in a little bit. And so, what you end up with from like an engineering organizational standpoint is you end up where you're managing these two things, and now instead of paying to manage one thing, you're paying to manage two. And so you see a lot of cost incurred there versus saying like, we are actually going to commit to moving all of our stuff, re-architecting a little bit maybe, or at least moving all of our workloads into cloud, into Kubernetes. Yeah. And you see a much better return there. And then on top of that, with that added abstraction layer, you get a lot better density with your infrastructure, which will ultimately save you money in the long run.
Yeah, I mean, I heard a talk very recently about transformation in organizations, and part of the argument was that there is a cost, and it's going to hurt, and you have to accept that there's a cost, because if you go in hoping to avoid the cost, you end up with something much more expensive, like you're talking about, where you didn't commit to either thing, and now you have both. But that's interesting. Any other thoughts on that question? I know it was a very big question.
I mean, the only other thing I would say is like, taking a step back and trying to scope down the problems you're trying to solve with Kubernetes, or with like, what problems the business has and how, like, what tool set can fix those problems. Just to, again, kind of scope things to make sure you're solving the right problems versus just implementing new technologies. And there's also an interesting anecdote from a book I've read, I forget what it's called, but it's this theory of like 36 hours of pain. So like a lot of people sometimes avoid making a difficult decision and drag that decision out a very long time. And a lot of times, sometimes just making the decision will just lead to about 3 days, that's not 36 hours, but 3 days of pain or so, and then like you kind of figure it out, and now you're in this new world and things like start happening. So if you're going to jump in with both feet, in my opinion.
Okay. If you're giving a pitch to somebody, developer or other SRE, what's your pitch for why you should Kubernetes all the things, and or do you give your friends warnings? Don't. It's hard. What do you say, and what's that pitch look like? I
would say just like kind of to your point earlier about it being the future of how orchestration is going to be happening. In this industry, it's like really hard to keep up with skill sets, and I think like any technologist should at least be poking around with it and trying to fix some problem they have maybe with it, or getting familiarized with it, just even from the aspect of like knowledge of where the industry is going. That would be, it's always my recommendation when somebody's like, what about this cube stuff? Just like, hey, check it out, try to do something with it. And if it blows your mind, then like start using it,
But this is the way the wind is blowing.
Yeah, it seems to be a lot of adoption for sure.
Yeah, and I'd like to hear Kim's opinion on this too. For me, as a person who's been in operations for a very, very long time, who is really looked at my role as serving an internal customer base, and that's like, the tier of developers that are building a product, right? And you have product people and user feedback all coming in to shape what that's supposed to look like, and they have a job that they need to get done, and they rely on infrastructure and delivery pipelines in order to be able to do that job. And when you take something like Kubernetes and you say like, yeah, you get control over what type of resources your job has, you get control over like what your scaling triggers are, you get control over how many of these need to run, you get a little bit more control over what reliability looks like for you, you get control over being able to do something like a canary deploy and what that looks like and how you test things out in production before going full sail with it. When you start to bleed that stuff out to developers and they start to be able to have ultimately a lot more control over what their stuff looks like running in whatever environment as they push things further downstream, you'll start to see adoption and ultimately a lot more developer happiness.
Yeah, my answer is very related to Lance's, but something like Heroku that's incredibly opinionated and it being locked into such a strict way of doing things, like developers, it gets so abstracted away, you just run a few commands and it happens. But eventually your business, if it's getting bigger, like Heroku's not going to be able to serve all your needs. And so give your developers the time to start playing with Kubernetes or start playing with cloud native technologies and see like, oh, we can control, how many pods are running here, or we can say scale up, scale down, or we can do all of these things and that we just couldn't do with something like Heroku. So yeah, open the treasure chest to your folks, and if they like it, go for it.
Sure. I mean, you want to see people in your organization be successful, right? And with developers, or as an operator, I've spent many times in Slack or face-to-face conversations saying, no, you can't do that. No, we don't have, we don't have the capacity for you to do that. Like, I'm sorry, well, that sounds like the next great idea, but we can't facilitate you doing that. And I think that some of those barriers take away a lot of those no's and put the control in the hands of the developer.
What am I not asking as a person who doesn't live and breathe the nitty-gritty of Kubernetes all day long? What are the things that I should be asking you about, or even you want to just talk about what's wonderful, what's terrible, what's a problem you solved recently that Kubernetes made easy, or what should I be asking that I'm not asking?
I think like maybe also some of the habits that would make a Kubernetes deployment successful are like, developers owning their code end to end. Like knowing what's happening in production. It's not like, just because they have all these tool sets and like knobs they can twist doesn't mean that like everything's solved. Like it gets you more in touch with like what's going on with your application in the hands of customers, their customers. So like, I think like a good like just habit and culture in a company is for developers to kind of own that whole life cycle from like inception to like in production running, providing value. And that I think helps also make like the agility of these kind of scheduling technologies, be realized.
How does Kubernetes enable insight into, like, historically a developer gave you their code and said, go get her, right? Get it done. And Kubernetes somehow enables them to have insight in and controlled access to and visibility into what's working, what's not. Talk a little bit about that. Like, how does Kubernetes enable this in a way that previously was more difficult?
I think it like reduces the ideation time. So like you can kind of POC something much more quickly without having like, especially when you're talking about like rack and stack world, like you don't have to requisition hardware, talk to somebody in a data center, have something actually be plugged in. It was kind of like the same transition from like, data centers to cloud technologies or cloud platforms. But even more so because like, you can kind of even do a POC in the extra overhead you have in your current assets. So I think it reduces that cycle time and can let people kind of solve problems in interesting ways.
So let's see, you said, what's a question you're not asking? I'm not sure what the question would be, but the answer would be Kubernetes doesn't solve poor application design, and it doesn't solve dev team culture issues. And so we work with a variety of clients, and it's really interesting to be able to compare just how different companies work. And our most successful clients, like their developers communicate well with each other, they're in good contact with us, and they build apps to the best of their ability. And our customers that struggle have poor team culture or have poor app design, and Kubernetes does not solve any of that. So it's not a magic bullet for not looking at things in your company that aren't going well.
And it doesn't grow Lance's hair.
And it doesn't grow Lance's hair.
Yet. A lot of community involvement when we figure that out. This hair is gray. I'm just going to go ahead and bring that hair down and launch a new one.
So yeah, I mean, you know, a lot of applications don't age well. So you know, it's analogous to that. So you.
You said that so deadpan. I thought you were getting into something serious.
So when you're asking Nick something, you kind of glossed over access control like really quickly, and I think that that's something that's really important to mention with Kubernetes. You know, running classic style infrastructure for so long, you know, whether you're running, you know, hardware machines that are racked stacked in a data center, or you have a hypervisor in there that's virtualizing it, or you're using even sort of like a you know, I'll air quote private cloud, but like a managed vCenter console, right, where you purchase resources from a provider that might be in your data center. You know, you're still dealing with access in a way that Kubernetes is further abstracted, right? You know, so many times you would get a developer that would come to you and say like, no, I need SSH access to prod. And as somebody who owns security, it's like that there is no way that's happening. I'm not, you know, you're not allowed to have SSH access to prod. No, I need that because I need to be able to, you know, get in, tail logs, or, you know, do whatever to figure, you know, to try to help troubleshoot and debug issues that they might be having. You know, Kubernetes, being a common API, abstracts that, and so you can use things that live inside the Kubernetes ecosystem, like RBAC, where you can create, you know, explicit roles, and you can use external auth providers to map to those roles. I mean, the granularity that you can access from a security standpoint that goes all the way down to individual deployments and applications that you can give developers access to is something, you know, from somebody who's owned security, you know, that's not something that I've really had at my disposal to be able to enable people to own their code, like Nick said, and still have me be able to sleep at night and say, you know, nobody's running amok while I'm not looking.
Yeah, I mean, and because of the additional layers of abstraction, like, you can control that all from your command line. And like, you don't have to put locks on doors for the server rooms because Amazon's taking care of that for you, or Google's taking care of that for you, or whoever, right? Like, you get the granularity in the software, but because we're at the point where there's been this much abstraction, you can do it all from your computer. And as a fully distributed company, you can do it from your computer in Colorado when somebody else is somewhere else. That's cool. That's a big deal. You're right. I did gloss over that. Well, thank you. This is our first time doing this. We hope there will be more, and we'll talk about other things and get into more deeper, more complex topics as we go. But we are Reactive Ops. All we do is Kubernetes, and our people, not me, are very good at it. See you next time.